Yeah, welcome to our webinar today about the best practices to deal with basically long-running processes, versioning of long-running processes, and migration of instances of these different versions. Just a few hints on the organization today. So we do a recording of the whole webinar, so we will provide that afterwards. If you have any questions, there's like a small question window right on the right in the GoToWebinar panel. If you have any questions, just ask them there as soon as they come, and we will do a Q&A session at the very end. And we will also provide the slides afterwards, so you don't have to basically clip everything in your computer. Who are we? So basically today, my name is Bernd Rücker. I'm one of the founders of Camunda. And with me today is Halil from Opens Consulting, a partner company here, basically active in Germany. And they did a recent project where they had a lot of versioning issues to solve, where he will describe a lot of the challenges and their implementation approach today. So I'm pretty happy to have Halil with me. Halil, do you want to maybe introduce yourself a bit?
Great, thanks. Hi together. I'm Halil from Germany, and I'm working as a senior consultant for Opens Consulting Deutschland GmbH. So mainly I'm working in integration and BPM projects, but I'm also focused on Java, web development, and architecture topics or other awesome stuff too. I'm living in Düsseldorf, and I'm happy to share my experiences today with you on dealing with frequent model changes of long-running processes.
Okay, great. Thank you. So I wanted to give a very brief introduction in the topic. So if you're looking at long-running processes, the challenge you have is that whenever, at any point in time, basically you have something running. So if you consider, for example, like a business process running for a couple of days, and you start them like every hour, all the time you will have running instances. And if you want to change your model, if you want to introduce new steps or remove other steps, or Halil will have a couple of examples later on, there are running instances. So you have to solve that somehow. There's a basic feature within the platform, within Camunda, which you can use, which is the versioning feature. So as soon as you have a new model, a new BPMN process model, for example, that gets a new version. So as soon as you deploy it in the database, it gets a new version. That's kind of just a number we increase as soon as you have a new version. And every process instance you run will keep running in the version it was started with. So that means you can, anytime you can deploy a new model, start new instances, they will use the new model, and the old ones will keep using the old model. There are a couple of details in there. Halil will focus on that later on. So our own version ID, for example, is just increased. So we have just an integer, which might be even different on a local machine than to the test environment, to the test stage, to prod. So this is not really very useful. But it's required internally. But we also know a version tag, which you can set yourself in the model, so you always can refer or reflect that this process model, for example, was part of a certain Maven version or whatever you use in your development. So that's the basic feature you have, and then you have basically two possibilities what you can do with that. So on the one hand, you can really run process instances in parallel. So that means you basically phase out all process models, so they just continue or finish in the version they were started with, but new versions start in the new version. But that means you can run a couple of them in parallel. Or what you can also do, you can migrate all instances of an old version to the newest version, for example. Then you don't have that different versions in parallel in your production system. We have kind of a recommendation in our best practices about that. So you might know our best practices. They are it's on camunda.com/best-practices, and that's available for our enterprise customers only. So you need a login for that. But there we describe typical use cases. And that means if you run the stuff in parallel, that's what you always do normally during development or in test stages because you don't care that much. Or if you really want to phase out the thing, or if migration is just too complex to do. On the other hand, you might want to migrate, especially if you want to patch something. So you might have a bug in your process model, which is really in the XML, and you want to patch that. Then you have to migrate, otherwise the patch is not applied to running instances. And that's something we want to focus on today. If you want to avoid running multiple versions in production, because that really increases the complexity in your operations. So these are basically the basic options. If we look at the project Halil was doing, and a lot of projects are doing nowadays, they're getting agile. And if you're looking in the agile approaches, and it doesn't matter if you're doing Scrum or whatever it is, or some kind of Kanban style project, what they all have in common, they release very often. So you have very short iterations for new releases. And that means that you might even start with only a small part of your process model. And you might already release that into production, and then you finish that later on, or you add nuts and bolts here and there. And if you do that correctly, that means you have to change the process model a lot. And that would mean if you really run that in production all the time, you end up with a lot of different versions. And that is typically not what you want. So if you ask your operation guys about what they think about that, it normally means that they actually hate it, because that means you might even have like sub-processes being called in different versions. So that means you have some kind of combinations with different versions, and that sooner or later will explode, and nobody knows which version talks to which version. And that's kind of a situation you cannot even test properly. So in such a scenario, it makes very much sense actually to really think about migrating instances. If you want to migrate that, it's typically a two-step approach. So the first step is you basically plan the migration. So you create what we call a migration plan. And in the next step, you apply it to your running instances. So that also allows, for example, to define the migration plan, to test it, and then later on to run it also in production. Defining that migration plan can be done in Camunda within just using Java API. So that's a very easy example. So you have version 1 and version 2 of the process. You just map all the wait states. So you map, okay, a process instance waiting in validate address will afterwards in the new version still wait in validate, oh no, in this case in validate postal address. So that might be a different state, for example. And this is how you can define the whole migration plan. And then in the next step, you can apply it, and that depends on how you want to do that. So that's kind of a Java API, so you could query for the instances and so on and so on. You can do the same thing using Camunda Cockpit, so the graphical user interface, and there it's kind of really a nice UI, so you can even map the stuff graphically. And whenever you're ready, you can either hit that run button and you can specify a query to really run it now. So we have customers doing that even in production, especially if there's not a really huge scenario. On the other hand, if you really want to test it, if you want to apply it in a like a proper way, it might be that you're using the basically the REST API and just download the JSON on Cockpit, and then you can automate the whole thing. Yeah, and that's basically the very quick introduction. So now we want to look into a real life use case, which I think much more interesting to hear from. So Halil, I basically wanted to hand over.
Yes, great. Thanks, Bernd. Okay, so let's have a look how we can use this great feature in a real-life project. So, well, first of all, I will show you why you should better use this great feature in an automated form in a real-life project. And according to that, I will show up some of the challenges from a real-life project to get it automated. So for this purpose, I've selected 4 topics in which we will have a deeper look later. Okay, so the first important question is, why should we automate the process migration instead of running it over Camunda Cockpit? Because it's a great feature of Camunda. For that, I've an example which will give us the reason for that. Let's have a look at it. So in this example, we have an IT project with 3 environments. Here, typically test environment, integration environment, and production environment. And the company has decided to work in an agile form and deliver small improvements after each sprint. So the team is only making 1 change per process and per sprint. And at the end of a sprint, these changes will be deployed to all 3 environments. So as a result, we have to run the process migration manually 3 times, so once per environment. I think that's okay, that can be managed manually, so we don't need to automate it for this scenario. Let's move a few months forward. And so, for example, our business goes well and the project has grown up. So now we have 4 environments. Additionally, the user acceptance test environment beside. And the number of processes increased to 5, and each process have 2 changes every sprint on average. So as a result, we have 40 manual process migrations after each sprint. And of course, this is a huge manual effort, and I don't want to be the person who has to run all these migrations manually after each sprint. Furthermore, this high manual effort means a high error rate too. So in summary, the automation is an important topic for this kind of BPM projects. And so now we can directly go to the first challenge if you decide to automate your project. So the first major challenge is to uniquely identify a semantic process version over all existing environments. For example, so let's say no matter in which environment we are currently interacting, we want to interact with the engine and so retrieve a process in a specific semantic version. And so we should get this one from the engine, hopefully. Of course, in first, this must also be ensured in one environment too. So the first idea is to use the versioning of the process definition by the engine itself. So let's have a look at an example for that. So if we deploy 2 changes one after another in a single local environment, for example, the process engine detects the changes in the model and creates a new definition version for it. It's simplified, listed in the table below. On the left side, the deployment order is listed. In the middle, you can see the sequence of a real semantical change of the process. And on the right, the generated process definition versions of the engine are listed. So it looks very handy, and I think so we don't have any big challenges and problems if we have this scenario. But let's go a step further. And so, for example, what happens if we redeploy all already deployed process definitions again? So simply we redeploy the semantic process versions 1 and 2, one after another again, and so that means that the deployment sequence 1 and 3 in the table here are the same, and 2 and 4 are the same too. So what the engine does is it detects the change to the previous version only and creates a new definition version for the process. However, the process definition is only an ascending version number and has no semantic meaning. And as a result, we cannot guarantee the semantical uniqueness of a process version across multiple environments. So in summary, we cannot use this feature for automated migrations. But as Bernd showed before, we can use the version tag input field in the modeler as a solution. So this is a Camunda specific extension and can be used for semantic versioning very well. You can set this information manually or in an automated way, however, as you like it. So personally, I prefer the automated way, of course. And this information is completely independent from the definition versioning and already visible in the cockpit too. So the only important thing is to define some conventions for the input data you want to fill it with and the time when these information should be set there. So, for example, you can increment and update it automatically on each Maven build with Maven plugin with the release and sprint number of your project extended by a sequence number. So this is done in this example here too. So as you can see, we have the second release. We are currently in the first sprint and have the sequence number 1. So this is our first change of the process. So in fact, conventions and the common approach is recommended here for this part. Okay, so with this information we can identify changes, and let's have a look at the second exciting challenge. So another importance is to make sure that no change on the models are lost during a sprint, or better, especially related to a sprint. For that, let's take a look at a simple example for it. So in this example, we have one team that handles 2 stories during a sprint, and each of which applies a change on a process. So the model on the top represents the first version and is already deployed on all existing environments. And now we want to remove the notify creditor service task from the model because the creditor shouldn't be informed in a successful improvement. And so thus we now have created the second version of our process here. And for the next user story, the model should be extended by a service task after a successful review here. That's our third version of the process. So as a result, the first user story deletes something from the process, and the second adds some information to the process. So we can't migrate from the first version to the third, or only from the second to the third, because we lost important business information or business cases from our process. And so as you can see, it's very important that all these changes applied in the correct sequence, and the changes must also be archived in any way, somewhere. Okay, so and given the fact that several teams work on a project, here, for example, Team A is working on the invoice process and Team B is working on the order process. It's also possible that each team work on a process in parallel. So all changes, or all these changes, need to be centralized somewhere to avoid a loss of any change. To summarize this point, so the solution must be able to deal with several changes within one sprint, and even with parallel working teams. Okay, so let's have a look for a solution for that case. To archive the changes, you can zip, for example, the models into an archive file and store them somewhere. So here in this example, I've pointed this archive with green arrows. It could be local in the project itself, or upload remote on a cloud service like Dropbox, as you can see here in this example. So in real life, or in projects, in real life projects, you should centralize it on one place. So keep in mind, both are possible, but you should define only one place, local or remote. For example, you can also put them on an FTP server in your company or on Nexus. It's possible too. So next, we create our migration plans with Camunda Cockpit, as Bernd showed before, and add them to the project for later execution. So here on this slide, I've called this place migration folder and pointed with the yellow arrow to it. These plans must be extended to the semantical information from which version tag to which version tag the processes should be migrated. So this is a manual effort which we must do. And so finally, you can reference and link the archive file and the migration plan in a central file. So here in this example called process changelog, which is pointed with the blue arrow. So all changes are archived in zip files, and all migrations are planned with Camunda migration plans. And overall, it is referenced in a centralized changelog file, which will be executed sequentially. So, for example, as a file format, here we've chosen JSON for easy readability and lightness. Okay, so that's solution to avoid to lost any change during a sprint. And let's move on the next challenge. So in real life projects, you have very often the case that you have the restrictions that the productive code must not contain any IT support code. That's equal, so that should be equal to database migration files, which you can't deliver with productive code too. So for us, that means that you must separate the code base and deliver several artifacts, as shown in this figure. The particular thing is that the productive code runs continuously, while the support code runs only one time. And so the artifact with P on front is a production code, and the artifact with M in front is a migration code. Either when we deploy it on an environment or when we release it, for example, it must run only one time. And so based on my personal experience, there are often other restrictions too. So for example, production environment is administrated in a completely different location, and the colleagues there should have minimal administrative effort for the migration, and only in special cases. And so in these special cases, there should not be an exchange of log files over mails with the developer team. So better, this information must be persisted in a central logging system, or even better, the responsible developer team gets an alert from this system too. Or the migration must be executed in a downtime of an application server for maintenance, as equal as possible with database updates. So as a result, that means for us that there exists no running process engine. So another technical restriction may be that the Camunda REST API is not delivered because only the productive application offers interfaces without having a third-party API beside. Or according to a modern infrastructure, the solution must also be able to be packaged in a Docker container so that it can be integrated into modern infrastructure. So as a result, based on such requirements, you have to select the right tools for your project. So so one possibility here is to implement a migration tool with Spring Boot, for example. That means the application server is down, and you start the Spring Boot application for the migration, and you can interact with with the engine to run the process migration without any application server. So this application can also be integrated into your continuous integration and deployment flow of your project. That can be maybe Jenkins or somewhat else. So that means the flow builds the application, the migration tool, and automatically starts the migration tool to migrate the processes without a running application server. And this small migration tool goes all the time with the productive code and run always once, except on the production environment where it could maybe it could be executed once during the maintenance work. So and the logging during the execution of the migration tool can, for example, be performed in the central logging system. So here I've listed graylog or papertrail, for example. Okay, so that's a quick solution to success the requirements which we have seen the slide on the last slide. Okay, so let's have a look to the third exciting challenge. Yes. So sometimes process changes require the manipulation of process data too. So, for example, to apply a new feature on running processes, a new process variable should be necessary to hold relevant information for further processing. So, in addition, it can also happen that you cannot migrate a process because of modeling restrictions. So one example for that is you cannot migrate a BPMN event element to a BPMN task element because they have different element kinds. And for these cases, migration API is no longer sufficient. But so in your real life projects, you have to be prepared for these cases too, of course. And so exactly for such cases, you can use the modification API from Camunda. So here's an example for the use of it. And in this example, here we extend the process for validation, and we want to rerun all waiting processes in a user task. So what we do now is to modify an instance that is not migratable, so that the process token is set on a BPMN element which can be migrated. And at the same time, we notice the returning point as a process variable. So let's call this variable return point. And after that, we run the migration, and if the migration is completed, we modify the process token again in the new version, and we move it forward to the defined return point as process variable in the process. Okay, I've prepared a demo to show you the automated migration on a particular example. But so first of all, I will introduce you to the business case. I've designed me for an order approval process with 3 versions. And so we will start with the first version and migrate it iteratively to the 3rd version. And so all the information will be logged in a logging system in the cloud. So I've choose papertrail for that. And the difference to a real example is that you have a CI or CD tool which will execute the migration. But for the demo today, I will execute it manually. Our first change is to reopen the rejected orders and notify the customer, and only when an order reopened. rejected. So that's our first user story to improve our business. And that's a change from version 1 to version 2. And to get our second user story done, we must add a validation for incoming orders before it will be assigned to someone as a user task. So therefore, we must use the modification API of Camunda to move the process token to the start event back, and so run the migration and modify the token to the new validation after migration back. And so I've prepared this as a video and let it simply run now. Okay. One moment. Don't really looks good. Give me a moment. Okay, that looks better. So, so as you can see, we are in our development environment, and so let's have a look at the process versions. So that's the first version of the process. As you can see, set with correct version tag, and so it's a simple, very simple process. Now let's have a look at the second version of the process, which is extended to reopen the order and notify the customer. And it notifies the customer only in the case where the approval fails. Okay, and in the third version of the process, we add the validation of the order, and so if the validation failed, we notify the customer too. So these are the three versions of the process, and after that we will have a look at Camunda Cockpit. So as you can see, there are no running instances existing, so no processes are running currently, and we have only the first version of our process. So now we will start a few processes to migrate them. So we do not need any input data because we are now focused on migration of the processes. So we have three processes now. And so as you can see, they are all three running in the first version of the process. So now I will apply the change of our first user story and deploy this change to the engine. It takes a few seconds, and so now after refresh we should see that there are now two versions of the process. Yes, so that's the second version, and so currently there are no processes running. Okay, so we stop our application server. And so let's have a look at our migration tool. So as you can see, and as described before, we have a process changelog with two entries. So the first entry refers to zip archive, which is within the project itself. The second entry references to an archive file which is uploaded to a cloud service named Dropbox. So let's have a look at it too. As here, as you can see. and it references a migration folder too. And in this migration folder, you can find the migration plan, which Bernd described before. The important information here is the version tag, which we added manually to migrate from version 1 to version 2. And so on the right side, you can now see Papertrail. It's a cloud-based logging, central logging system. So, and now we run the migration, and in the correct way, we should see on the right side that the informations are logged out in Papertrail. So, as you can see, there are some information displayed in Papertrail, and it displays that the migration was successful, and now we will start our application server again. As it takes some time to refresh. Here's the browser. But we should see that there are no processes existing in the first version now. And so if you have a look at the second version, so as you can see, there are 3 processes which was migrated from version 1 to version 2 with the same business case. Okay, so now we will execute our next user story and apply the changes on the model and deploy the change model to the engine too. Okay, so let's have a look at Camunda Cockpit. So we should now see 3 definition versions. Yes, so and the validation was added, and so in case of failed validation, we notify the customer. Okay, so we have 3 processes in the second version, and we want to migrate them to the third version. I've prepared the extensions in the migration tool for that before, and so I will revert this. Yes, so first of all, you can see the third entry in the process changelog. So the version tag is set here correctly too, and the archive file is uploaded to Dropbox equal to the second version. And so we reference a new migration folder here called approve order version 3. And so the special feature is, so the version tags are set. Okay. And so we have 2 more JSON files. It's called modification before, which moves our process with the modification API to the start event and set a return point process variable, and modification after JSON file, which adds additionally a process variable named valid, and which has type Boolean and the value true. Okay, so let's start our application server. Stop our application server again to run the migration. Okay, so we start the migration, and on the right side we can see that Papertrail logs information about the migration status. Takes some time, but we see that the information was logged out, migration successful. So now we start our application server, here in this scenario Tomcat. And so after refresh, we do not have processes in the second version because they are migrated to the third version. So let's have a look at the third version. So as you can see, we have now all existing processes migrated to the latest process version. And so deeper look in process variables, so we can see that there is new process variable named valid, is the correct value. Okay, so let's go back to our slides. That was all for the demo, and so as a conclusion, so finally we can say that the engine, the Camunda Process Engine, offers a very flexible and well-documented API on which you can build your own toolings and tools around the process engine. The second point is you can build a good technical base for your continuous improvement process with automated process migrations. And personally, that's the point where such a project will be very interesting for me myself. So the next point is you don't have to care about the versioning of the source code because you are always on the latest process version. And you have, on the other side, you have always the latest source code version. So you don't need to think about versioning your source code with any historical process versions. So, and finally, as a request from my side, so it will be great if the APIs of Camunda will be extended by the version tag information and the process definition key, because you don't need to extend it manually then. Okay, so that was all from my side, and so I will give back to Bernd.
Bernd, sorry to interrupt. We can't hear you.
Yeah, sorry. Thanks, Khalid, for sharing your experience in the real life project. I actually don't have anything to add at the moment. I just collect the questions. So what I want to do is I want to go quickly over them. So there was one question about, let me quickly check. Yeah, the first question was about basically the source code for that migration solution you did. Is that somehow available, or is it possible to get it, or?
So currently we have not uploaded it somewhere, but we are planning to upload it in the next weeks on GitHub. But if you need it before, you can contact us directly. So you can contact Bernd or contact me, and so we find a way to share it with you.
Okay, great. The second question was about how much effort it was, or how complex was it to build the whole migration thing you did. I mean, it's pretty advanced what you did, and so the question was that kind of a huge thing, or?
So it takes some time. So let me tell it as so we have done it in agile form in sprints, and to summarize it up, it was so 8 weeks. 8 weeks we have worked on it. The problem is you don't have the problems or the challenges on start of the project. So you are working from one challenge to next.
But that was basically not 8 weeks full time, but it was on like the 8 weeks of doing sprints. You did that.
Yes.
By the normal development. Okay. I also got the question, but I can answer that myself. Is that required to do that much work for process instance migration? And the typical answer is it really depends. But if I look over our customer base, I would say not that much customers do it in such an advanced way, like what Halil presented, but not so much of them are really releasing every sprint, for example. So you don't have to go that far, actually, but I think it's a good idea to think about it very early. And what at least basically a lot of customers are doing, and actually all of them should do, and we recommend that in the best practices as well, is to at least set the logical version, so you're not tied to the technical versions we set. So that's something you definitely should do. And then you can also easily leverage the version migration. I made a note about Halil's feature requests actually already in advance, so that's kind of in the backlog. There was another question. Yeah, that's an interesting one. So has the production server to be stopped while doing a migration?
Yes. So it's not necessary, but the problem is the running processes should working currently, and if you try to migrate the processes, it can be yes, you can get some problems because during your migration the processes are running.
Mm-hmm. Yeah, so I would summarize it as it's definitely possible, but you might run into issues whenever you do something. For example, at the same time you start new instances, but you already started the migration, and
Yes.
you might also access the same instance with migration and runtime code. So it's not impossible to solve that, and there are a lot of things in Camunda which solve that. For example, we leverage optimistic locking very much, but then you have to think about these kind of situations. And normally, I think you would do it with a running production server if you have a lot of load, and then you might really run into these issues. So it makes the whole thing a bit more complex, I would say. There was another question. I still try to understand it completely. So it was about the history aspect of instances, how that is handled. I'm not sure if you can or want to say directly something, Halil, or.
Could you yes, some more details about the question?
No, I don't have any more details in the question at the moment. So okay. I try to guess. So my guess, and the guy asking the question can refine the question if he wants to. So I'm still seeing new questions coming in. And my guess would be, so basically, how is everything in the history handled when you migrate? Because if you migrate, I mean, kind of the history trail you have might not fit in the model you have anymore. So you might, for example, in the history trail, you might have visited an activity which is not there in the new model. And did you handle that somehow? Did you basically ignore it? How does that? Does that pose some question, some problems when you look at it in Cockpit and so on and so on?
Yes. In the real life project, we have defined a transaction to do not migrate it partly. So if we start our migration tool, it runs, and if we get some failure somewhere, we do roll back the complete migration. So that's the first point. The second point is we interact with the engine and set the history level of the engine to full. And so that means if there are some process changes, it will be persisted in the history database too.
But you don't do anything to modify the history of migrated instances, right?
No, specifically.
Yeah, that's actually what I know from most of the customers. So if they use version migration, which actually a lot of customers do, they actually don't take care of doing anything in the history, which is normally not an issue. I mean, you still have the history. You just have to be aware that there might be situations in the history which are hard to explain by just looking at the current model. there's one additional thing, Halil just mentioned it. We write a history event or a history log about the migration itself, so you get a hint that there was something happening at that time. So that could help as well. There was one. Let me quickly check if I've missed something. There was one question about actually about the download link and the webinar recording. So what we will do afterwards, we will send basically an additional information via email if you registered for it, where you can access the recording and also the slides and these things. So I think there were two very detailed more questions which I will answer privately. So there's nothing more to say at this moment. I just want to, basically want to thank you, all of you, for attending. I hope that was kind of helpful for you. If you have any feedback, let us know. You have the contact data. If you want to get something from the code, let us know as well. And thanks for coming. I wish you a nice rest of the week. And till next time. Thank you.
Thanks from my side too. Bye.